Welcome back. I hope you enjoyed that little detour, learning to integrate OpenCode or Claude Code with Solana. Fun side quest, right? Well, today we are putting our hard hats back on. Welcome to this Forge College Explainer. We're tackling Capstone, assemble the EVM execution flowchart. Now, this is a pivotal piece of our Analyzing EVM Execution Flow Capstone, which sits right inside the EVM Deep Dive Execution and Environment module of our broader Ethereum fundamentals track. Wow, that is quite a mouthful, but basically today we're acting as master architects. This is the exact moment where all your hard work on execution analysis totally crystallizes into one master diagram.
So taking a quick glance at our agenda for today, we'll be covering our context and material setup, defining our acceptance criteria, actually building the blueprint, running a strict quality checkpoint, and then finishing up with our next steps.
All right, part one, context and materials setup.
Okay, so what actually is an EVM execution flowchart? Think of it as the ultimate synthesis of all the analysis you've been grinding away at in our previous lessons. We are taking that huge, tangled mess of raw abstract data and turning it into a comprehensive, reviewable deliverable. It's literally the master map of your execution flow. You wouldn't build a skyscraper by just throwing steel beams into a pile and hoping for the best, right? Same exact thing here. We're taking raw lumber and engineering it into a sturdy, well-documented house.
And these are our raw materials, our steel and bolts, if you will. We've got our scoping boundaries, which basically tell us exactly what transactions to include and, perhaps more importantly, what to safely ignore. Then we have our annotated traces, serving as our concrete execution evidence. Next up, our prioritized bottlenecks, so we know exactly which nodes need the most visual emphasis. And finally, our mitigation plans and standardized stencils. You absolutely need all four of these sitting on your drafting table before you draw a single line. Moving right along to Section 2, the acceptance criteria.
Before we start building, we have to know what actually passes inspection. This rubric translates our success criteria into verifiable, concrete checks. We're not just guessing here. We validate the end-to-end mapping by making sure absolutely every single call has a corresponding node. We cross-reference to ensure those top 5 bottlenecks are clearly highlighted. We actually demand trace evidence links, meaning we match the opcode offsets. And we need punchy 1 to 3 sentence actionable mitigation plans. Plus, there's a strict legibility check. If a reviewer has to squint at 100% zoom just to read your text, guess what? It is immediately back to the drawing board.
All right, Section 3, building the blueprint. Let's physically step onto the construction floor. These 4 chronological steps form our assembly workflow, magically turning raw transaction data into an elegant top-down schematic. First, you convert your trace data into nodes and edges. Second, you lay those nodes out in a logical top-down call flow order, starting from the external call and cascading down to the children. Third, you apply your highlights and slop on that mitigation text. And fourth, you export a high-res PDF alongside your machine-readable metadata. It's a highly systematic process, kind of like laying bricks one by one. Now, a huge pro tip for step 1. Diagramming tools require standard inputs. Please, whatever you do, do not manually copy and paste thousands of lines of hexadecimal data. You will literally lose your mind. Instead, use a quick utility script to extract your trace IDs, types, addresses, program counters, and opcode windows right into a simple JSON or dot file. This feeds perfectly into your chosen diagram editor. We always want to work smarter, not harder, right? Which brings us to Section 4, the quality checkpoint. Before we even think about shipping this schematic to the chief architect, we have to run some QA. Because there is a massive contrast between an amateur sketch and a professional engineering document. A failing flowchart is missing its trace evidence, it's totally unreadable at standard zoom, and it lacks that programmatic metadata JSON file. A passing flowchart, on the other hand, embeds trace evidence links right into the nodes, features concise mitigations, and uses perfectly clear standardized stencils. It proves its claims with hard, observable data rather than just looking pretty. To guarantee you pass, just run through this checklist. Map 3 representative nodes back to their exact trace lines. Confirm your top 5 prioritized bottlenecks are visually popping. Do that legibility test at 100% zoom. And run a quick programmatic check to ensure there are absolutely no missing JSON trace references. If you hit all of these, your flowchart is rock solid, and any reviewer can follow your logic seamlessly.
Finally, Section 5, next steps and wrap.
As we pack up our tools, I want you to internalize the golden rule of EVM architecture. Always attach direct trace references to your optimization claims so reviewers can reproduce the observation. It is literally the Web3 engineering equivalent of "pix" or "it didn't happen." Without the trace evidence pointing to the exact opcode offset, an optimization is just a nice theory. But with it, it's an undeniable fact.
So how does this set us up for the future? Well, next up in our module is define gas and core units. Your newly minted schematic clearly shows exactly where the execution costs are concentrated, so keep that flowchart and metadata handy. We're going to take these visual hotspots and translate them into concrete, measurable gas metric targets.
Which brings us to a final thought for you to chew on. How will your visually pristine execution blueprint hold up when we finally attach cold, hard gas costs to every single node? It's going to get very real very fast. I really hope this explainer helped you master the assembly of your EVM flowchart. Remember to visit forge.college to continue mastering the EVM and all sorts of other Web3 subjects with us. Thanks so much for tuning into this Forge College explainer, and I will see you in the next one.